solving trigonometric equations. This is a homework assignment that I am going to work out through you on this live stream. And basically what we're just going to work on is solving trigonometric equations. I am going to work through 6 different examples as far as least free response, so I'll kind of explain my work. I am going to work through them. We discussed in my class finding all the solutions as well as between 0 and 2 pi. Did I do the reciprocal? Yeah, I did do a reciprocal. So that's what we're going to go and work on, and then what I'll do is I'll go ahead and take a break and I will go ahead and supply the multiple choice. If you have some questions that you would like to ask, feel free to add them into the chat, which I forgot. Actually, I got to pull. No, I did pull up the chat. Okay, cool. So I can go ahead and see you guys as you add in. Let me see. How are you doing? So you have some angle of depression. I can definitely answer that. I'll go and take a look. Layla, how are you? Good to have you in on the chat. So what I'll do is I'll kind of work through that. I'll take a quick little break, kind of see if there's any questions, anything else in the meantime, and then I'll knock out the free response. Last live stream I did not have enough time to answer any questions, but this live stream, hopefully, if I have some questions, I can go and answer them to you. As I know many of you guys are getting back into this, getting back into the school grind and getting ready for upcoming tests and all that kind of stuff. Just also a reminder, if you actually want a copy of this as a PDF as well as my PDF answers, that is something that I do offer in the kind of the YouTube membership kind of side, the join kind of button. So if you want to go and check it out, I am looking into doing some new things. I mean, one of the things I do provide is these, as well as my notes that I provide my students. Basically the guided notes, so they can kind of see more examples. So the homework I kind of go through a little bit quicker, and then the guided notes I do a little bit more in detail and do more examples of them. So if that's something of interest to you, you're taking pre-calculus, algebra 2, college algebra, feel free to go and check it out. If it works for you, awesome. If not, I will be continue making videos throughout the rest of the year, as well as doing live streams. So happy to answer your questions. Sir, what question are you doing? I am doing the questions on my homework assignment that I assigned to the students. So this is actually an assignment that I gave to my students today, asking them to complete it. And we have a quiz on Wednesday, so I want to make sure that they have a opportunity to review my answers and their answers before their quiz. So, did you strike today? No, I heard about the Los Angeles strikes though, but I am in Jacksonville, Florida, so we did not have any strikes from there. So, hey Mark, how are you doing? And Kitty Gamer, good to see you. This looks a little hard. Yeah, it could be sometimes. I mean, it's really just a process of getting used to everything. So that's what we're going to, kind of work on, is I feel getting through this assignment, getting a little bit used to this. And obviously you haven't even taught this lesson yet, so wait till tomorrow and you'll see it's not that bad. But all right, guys, I am going to kind of work my way through here, and then kind of mid little halftime, I will check in with some of you guys and just say hello. Happy you guys joining on the stream, and let's go ahead and get started. So basically, the only question that we have here is solve. We're basically looking for finding the solutions. And on our notes, what we did talk about in classes, solutions are the values that make the equation true. Values that are going to make the equation true, when we have our set equal to 0, or basically values of x when y is equal to 0, basically looking into another way of looking at your roots, zeros, x-intercepts, so on and so forth. So basically we want to solve for our unknown variable that is going to make the equation true, right? And you can see here that each one of them have these variables. Now sometimes I don't think I really said that correct, as far as I think that's why I was talking fast, but basically we're looking for the value of the variable, which I use different variables here, that is going to make the equation true, right? Now, the important thing that I want students to kind of come away from this is when we're doing these types of problems, a lot of the algebra that we're doing is nothing more from Algebra 1 and Algebra 2. So, even if you are taking Algebra 1 and Algebra 2, you can definitely do all these problems. And the way that I kind of recommend this for these first two problems, I'm going to use this notation. Forget about tangent of alpha, right? Let's just pretend it's an x. Whoa, how did that get switched? All right. So let's pretend I have 3, square root of 3, x minus 3 equals 0. Right? Like, let's pretend we're in Algebra 1, Algebra 2, and I say solve for x. Like, what would you do here? Well, you would, to isolate the x, you would add the 3 to both sides. And then you'd have 3 square root of 3 equals 3. And then you divide by 3 square root of 3. And, oops, sorry, there's an x, right? And then you'd have x is equal to 1 over the square root of 3. And you could go ahead and rationalize that denominator by multiplying by the square root of 3 over the square root of 3, and you get the square root of 3 over 3. Now, I'm not going to delete this. I'll kind of put this over to the side. But that is basically what we do in Algebra 2, right? So it's really kind of like the same process, okay? For solving trigonometric equations, it's just now we're going to use, obviously the trigonometry to help us solve for the value of the variable. And that's where a lot of students get tricked here, is not so much of the solving. They usually, with practice, get caught up there. But where students usually have a lot of trouble is remembering the unit circle. So I told my students today, if you are one that has already lost the I've already lost all the points on the unit circle, it would be a good time now to go back and start reviewing the points on the unit circle. So I will, for this homework assignment, obviously go ahead and recreate some of that. And then we know that's equal to the square root of 3 over 3. Okay, so basically we have an equation, tangent of alpha is equal to the square root of 3 over 3. Like, what values of alpha, or the tangent of what angle is equal to the square root of 3 over 3? Now, again, this has been a while, and tangent's really not that fun anyways, right? So let's go ahead and draw the first quadrant of my unit circle. Actually, you know what? Let's see. I'll just put it right here. Hopefully we'll have enough space. I think I've been getting better with drawing circles on this pad. First couple times I did this, it was like absolutely horrible. But I think I'm doing a little bit better job. Maybe, hopefully. All right, I feel like I need to like zoom in though. All right, so this coordinate point is, we know is going to be square root of 3. I kind of want to go actually a little smaller. Square root of 3 over 2, comma, 1/2. This coordinate point is square root of 2 over 2, comma, square root of 2 over 2. And this coordinate point is 1/2, comma, square root of 3 over 2. Now, I'm not going to write in the angles, but you should remember this one is pi over 6. Here is pi over 4. Here is pi over 3. And then that's pi halves, right? And then all the way halfway around circle is pi. All the way around circle would be 2 pi. Okay, so we're looking for the tangent of the angle alpha when, over the y coordinate, over the x coordinate is going to equal to the square root of 3 over 3. So basically, when is the y coordinate over the x coordinate going to equal the square root of 3 over 3? So hopefully, obviously, this is analytic trigonometry, so you've already passed the trigonometry portion. So I am going to see that this graph is going to equal alpha, at least in the first quadrant, is going to equal pi over 6. Okay, I'm not going to go through the algebra here, but if you take the y coordinate over the x coordinate, 1/2 over square root of 3 over 2, you would get square root of 3 over 3 once you simplify it. Okay, now that's not the only angle though, where tangent is equal to a positive. That is not the only angle where it's equal to a positive. Where am I looking at? Positive square root of 3 over 3. Because remember, tangent is positive in the first as well as in the third quadrant. So then we got to think, well, what is this point over here? Oops. So let me actually, let me draw this over here. So never mind. I'm not going. We're going to keep that. We want that. But let's draw what this triangle is, which would be over here. Because this is kind of important to see this. So we have our one angle, pi over 6, and then we have another angle over here, which that angle is going to be 7 pi over 6. Now, 7 pi over 6. So we have pi over 6, and then we have 7 pi over 6. Okay. Now, it would be great if I was to go ahead and graph these and you guys could see the graph, but I kind of spent all class period teaching my students this, so I'm just going to focus on the algebraic technique and looking at the unit circle. But I would recommend graphing this equation so you could also see the graphical portion of this. I think that's really helpful, especially if you need some understanding. So anyways, here's our two solutions, but these two solutions are only between 0 and 2 pi. So these are really our answers for B, right? But if we want to find all solutions, remember that like the graph of tangent, it continues. Like you have infinite many intervals going around the unit circle. So there's going to be infinite many, solutions here. But how are these solutions related to one another? And hopefully what you can see here is there's some patterns here. From pi over 6 to 7 pi over 6 is a distance of pi. And if I add pi again, I'm going to go back to the same coordinate point. So, sometimes one thing I, showed my students is if here are my two angles, we have two basically terminal sides that create a point that is a solution, or that has an angle as a solution. Well, if you keep on adding 2 pi to both of those angles, you're always going to get, so here's A, you're going to get all the solutions, 2 pi n plus 2 pi n. And that is correct, right? But that's not really the simplified version. The simplified answer would just be to take the smallest positive angle, which is pi over 6, and add pi n. Because if you take pi over 6 and you add pi to it, you get 7 pi over 6. If you add pi to it again, you're going to get 13 pi over 6. And you can keep on adding pi to get all the solutions. You could also have n be negative numbers and you go in the negative direction. Now, as far as finding all the angles between 0 and 2 pi, that's basically just looking at the angles that are in the unit circle, which I'm going to write as a solution set here as pi over 6 and 7 pi over 6. All right. So there you go. That's the first answer. Kind of took a little bit long time on that one. Hopefully the rest of them don't take as long. But let's go through the kind of algebra 2 again on this one. If we were to look at this equation just in terms of x's, we would have x squared minus 2x equals 3. Right? And hopefully your Algebra 1, Algebra 2 teacher, you'd recognize, oh, this is a quadratic. And to solve quadratics, especially when I have two variables, I'm going to want to set this equal to 0 and look to either factor it, quadratic formula. So we subtract 3 here, and I get x squared minus 2x minus 3 equals 0. And thankfully, this is factorable. So I could do x minus, not 3, yeah, x minus 3, and then x plus 1. Right? Now, I'm not going to solve this, but what's important about this is I would do the exact same thing here with cosine. Like, you're going to subtract the 3, so therefore you have cosine squared of x minus 2 cosine of x, 2 cosine of x minus 3 equals 0, right? So now, like, we just need to factor this. So you can basically just steal what you did here with x's, because it's the same thing instead of x's. And sometimes, what I even wrote my students is use what we call substitution. Like wherever you see a x, replace it with a cosine of x, right? Or wherever you see it, so now we can just take this solution here and then use that substitution. And therefore I have cosine of x. Now, that was not a really good idea. Cosine of x minus 3. And then I have, cosine of x minus 3, and then I have, cosine of x minus 3, and then cosine of x plus 1. Okay, so now I have the product, right? So now I have basically going to be the product of two terms. The product of two expressions equal to 0. All right, and now what I'm going to look at is just apply the zero product property, just like you had set here. So I can set each factor, cosine of x minus 3 equals 0, and cosine of x plus 1 is equal to 0. So now when I go ahead and solve, I get cosine of x is equal to 3, and cosine of x is equal to negative 1. Okay, so now let's go ahead and think about, looking at our unit circle. And the important thing about cosine of 3, if you remember from inverse functions, that is not going to fall within our domain of our inverse functions. Think about what angle when is cosine equal to 3. So maybe you can think about this as far as the graph, actually. So if you were to look at the graph, let's just draw a rough sketch of cosine real quick. So here's your cosine graph. Up 1, negative 1, right? 1, 2, 3, 4. 1, 2, 3, 4. Okay, graph looks something like this. Okay. For what angle of the graph does it equal 3? And remember, the graph only goes up to 1 to negative 1, right? So there is no angle. When you take the cosine of your angle, remember, this is your input, this is your y coordinate, right? Y coordinate, x coordinate. It doesn't matter what angle you plug in for x. You're never going to get a y coordinate of 3. So this is, does not exist. This is not going to be a solution, right, of your equation. So the only equation here we're going to have here is cosine of x equals negative 1. And so looking at that on the unit circle here, we can see here's my angle right here. All right. Now, as far as finding all the solutions, well, if here is my solution here, the next time to get to the next solution, I got to add 2 pi. I got to do a full revolution. So my solution here is going to be x equals pi plus 2 pi n. And yeah, so it'd be pi plus 2 pi n, where n is going to represent any number. And if I just wanted to find the values of b between 0 and 2 pi, I would just say, x is just equal to pi. All right, now let's go ahead and stop. So now let's go ahead and look at this next equation. So this one's kind of interesting because it kind of looks a little bit weird, a little bit different than what you're kind of used to. But, remember when we went back from Algebra 1, which I was kind of saying, like these two equations, you either have one variable and you're using inverse operations, right, from Algebra 1, or you have multiple variables and you're using factoring, right? I mean, that's basically going to be the two ideas that we are going to be exploring here. So, kind of going back to the Algebra 1, Algebra 2 idea, like we have basically variables or unknowns on both sides of the equation. Well, to solve, we got to get them on the same side. So I'm going to add, let's use a different one. Let's use red. Let's add a sine of theta to the left and to the right. When doing that, I get 2. Sine of theta is equal to the square root of 3. Now, to isolate my trigonometric function, I will divide by 2 on both sides, and I get sine of theta is equal to the square root of 3 over 2. Okay, so we think about this, we say, all right, so when is sine of theta equal to the square root of 3 over 2? Well, if we kind of go back to our unit circle, understand the unit circle, square root of 3 over 2, that's going to be pi over 3. But remember, it's not just pi over 3 because sine is positive in the first and the second quadrant. So we have pi over 3, and then we also have this angle, which ends up being 2 pi over 3. Now again, notice the difference between these two angles is not congruent. Like, I haven't done it. Like, see here, I could add pi would take me to the next angle, right? And if I added pi again, it would take me to the next angle. Over here, the distance between these is pi over 3. So if I take my first angle, pi over 3, and I add pi over 3 again to it, I get 2 pi over 3. But if I add pi over 3 again, that takes me to 3 pi over 3, which is not a solution to this equation. So therefore, what I need to do to find all my solutions is I need to take both of my equations, theta, and then which is theta equals pi over 3, which is the first angle, and then just add 2 pi n. And then I need to take the second angle, which is 2 pi over 3, and then add 2 pi n. And that will satisfy all additional adding in the positive or in the negative direction, where n can represent any integer, to give us all of the solutions. And then for B, B is going to be find all the solutions between 0 and 2 pi. So obviously that one's kind of nice because I can just write this as a solution set as far as just what's on the unit circle. All right, so now let's get to a reciprocal function. Awesome, love it. So, now that we've spent some time with identities as far as the reciprocal identities and the cofunction identities, there we go. We're pretty used to remembering that, that the cosecant is the reciprocal of sine, the secant is the reciprocal of cosine, and the cotangent is the reciprocal of cotangent. So, same process that goes into this problem as the other ones, like isolate the trigonometric function. So the first thing we're going to want to do here is divide by 3. Okay, and when we divide by 3, we get cosecant squared of x equals 4/3. Now, I need to get rid of the square root, so I'm going to introduce the square root. And I did this with all 3 of my classes, and every single one of my classes got this problem wrong. And what they got wrong, which you got to be very careful with, is when you take the square root, remember, from the beginning of this year, if you've watched any of my live streams for this full year, at chapter 1, chapter 2, chapter 3, like every single time we came across this, we always talked about making sure that you have plus or minus. So I can rewrite this as the square root of 4 over the square root of 3, which equals plus or minus 2 over the square root of 3. But every single class that I gave this to today, and I hope none of my students for tomorrow are watching this, because it's really important to see people get that wrong in front of everybody else so we can talk about it. So even if you are watching it and you're in school tomorrow, just make the mistake on purpose for me, please. Because what we do is we put it on the board and people can see the mistakes and we talk our way through it. But anyways, just a little joke. So here we go. Here's the cosecant, right? Is 2 over radical 3, plus or minus. Very important. Because if you don't do plus or minus, you're missing half of the answers, right? And I even asked the students, I'm like, so what grade do you deserve if you miss half the answers? And they're like, 50%. And I'm like, well, I'm actually even a little bit nicer on my grading policies, the way that I have my grading policy set up. So you'd actually earn a little bit more than 50%, but it's a very serious mistake it's a very minor mistake, but it causes a very serious issue, right? So you just got to be careful, very careful. All right. Now, the important thing now that we know our identities is rather than trying to figure out what on the unit circle is cosecant, we know that sine is just the reciprocal of this, right? Cosecant's, the hypotenuse over opposite, or 1 over y. Sine is y over 1. So we can just flip this around, right? Because they're reciprocal identities. And this is much easier. This is just like the last problem. Not only, though, is it positive, it's also negative. So let's go ahead and draw what this triangle would look like. So now we have pi over 3, 2 pi over 3, and now we have when sine is negative as well, right? So we have, 4 pi over 3 and 5 pi over 3. Now, what a lot of students will do is when they write their answers is they do all of them. They do x has to equal pi over 3 plus 2 pi n. X has to equal 2 pi over 3. And I don't know why I'm going to do this, but I guess I'll just figure I'll write it all out. 2 pi n. And then they write x equals 4 pi over 3 plus 2 pi n. And then they write x equals 5 pi over 3 plus 2 pi n. And I actually kind of like when they write them all out because I say, you just spent a lot of time writing all of this. Is there maybe an easier way to write this? Because if you give this to me, my answer, and I don't say give me the most simplified solution, that's right. You provided all of the solutions, right? Exactly what I was asking for. But, if you look at this, here's pi over 3. And then you can also look at, so between here and here is, so here's pi over 3. Now, these are, let me actually draw these a little bit better. Just so you guys can get the full effect here. I think I did a pretty good job. But just to make sure I don't want any confusion, because I didn't do a pi over 4 one. All right. So here was my point I was trying to say. Here's pi over 3. Well, if you add pi over 3 again, you're going to get to the next solution. But again, what we came up over here is you add pi over 3, you're not getting to another solution, right? But if you guys kind of look here is 2 solutions, which are pi away from each other. Here is 2 solutions, which are also pi away from each other. So even though this is correct, could we simplify this? And the answer is yes. A simplified version would take the smallest positive angle, which would be pi over 3, and then say, what else would you need to add to get to another solution? Well, you could add 2 pi, but if you just add pi, that takes you to the solution in the third quadrant, and if you add pi again, that goes back to your original equation. So I would write x equals pi over 3 plus pi n. And then you could do it the same one with the second and the fourth quadrant by saying x equals 2 pi over 3 plus pi n. All right? And then to find all the solutions in the on the unit circle between 0 and 2 pi, I'll just do a solution set here. That's going to be pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. All right, we got 2 more guys, and then I'm going to take a little break. So I see some of you guys are in the chat. It looks like you're having your lone little comment. That's cool. But if you guys do have any questions or anything else, I'll be happy to answer. It looks like, yeah, you guys have been chatting it up. Cool. All right, well, hope you guys enjoyed the stream. Maybe some of you this has been helpful. But again, if you have any questions or if you have anything questions as far as what I'm covering, let me know. I'll be happy to kind of further explain anything that's going on. Oh, I guess stream's all right, right? Okay, so we have 2 secant of 2x is equal to negative square root of 2. So again, we have another reciprocal function, right? And then now we have this little 2x. Now, here's a little trick. If you don't know what to do with that 2x, why don't we just use substitution? Why don't we just say theta is equal to 2x, okay? So I'm going to do this problem and just kind of pretend right now that 2x doesn't exist. So let's go ahead and solve for secant of theta, and then we'll replace the 2x once we get our answer. And that's exactly what you want to do. Now, you don't need to actually replace 2x with theta. You could just keep rewriting 2x. But as you guys kind of notice that sometimes it comes redundant. It's like, oh, it's a lot of writing of 2x, 2x, 2x. So in this case, I'm just going to divide by 2. And that is wrong. That's supposed to be a cosine. I did not check my answers on this one. So let's do this as a cosine, because that's a mistake. My bad. Because there is no secant that would equal, actually, so if I did 2 over negative square root of 2, rationalize the denominator, yeah, give me square root of 2. That won't work. Okay. I guess was that what I was trying to do, square root of 2? I'm not sure. Let's do another secant one, so I'll have to change this. Why don't we just get rid of the 2? I'm not sure what my original 10 was. Let's just get rid of the 2. All right, so therefore, our operations now are a little bit easier. We just have negative square root of 2. Now again, we can rewrite this using our reciprocals, and we can say the reciprocal of secant is cosine, because I would like to use that. I would like to use the reciprocals again, and that's going to be 1 over negative square root of 2. Now again, rationalize the denominator, and you get negative square root of 2 over 2. Okay, so now we got to think, well, what angle is that on the unit circle? Like, when is cosine negative? And remember, cosine, that's going to be, cosine's negative in the second as well as in the third quadrant. And if you remember, that angle is going to be in the first quadrant is pi over 4, right? That's the square root of 2 over 2, common square root of 2 over 2. So in the second quadrant, we're going to have an angle, theta equals, second quadrant would be 3 pi over 4. And then we'd also have theta equals 5 pi over 4. Now again, this is not a solution, right? So I actually got to be careful. You can see here there's no kind of, I wouldn't say symmetry, but there's no way that we can add between these two angles. I basically just need to add 2 pi to both of them. So add 2 pi n. Okay. So that would be the solution if we were just solving with a single theta, but remember theta equals 2x. So now what I'm going to do is I'm going to replace my theta with 2x. Let's see, do I have some space? I do. Okay, now this is where a lot of students have trouble. Okay, so if this is a sticking point for you or having trouble, pay attention. So now, to solve for my x, which is, again, the whole purpose of this whole video, like this whole thing is finding the solutions, right? We're just going to divide by 2. Now, that's not the hard part. So when we solve for x, we get x equals 3 pi over 8 plus pi n. And then here we get x equals 5 pi over 8 plus pi n. Now, I wish if I had more time, I would go over at least like, you know, n representing any integer. But again, like n could be 0, it could be 1, it could be 2, okay? So here are the answers for all the solutions. Now, that's fine. Usually students get that you apply the substitution, they divide, and they get the answer. Where usually students have trouble with is finding the solutions between 0 and 2 pi. And to really understand this, we got to think about what is happening to the graph with that 2x, right? You know, forget about the negative square root of 2. Like if you were to put that over, that's just shifting the graph up or down. That's not actually affecting, you know, where these solutions are going to occur. What we're concerned about is that 2x. Like what that has done is that has compressed the graph. That's horizontally compressed the graph. There's going to be more solutions, right, that happen between 0 and 2 pi when a graph is compressed compared to when it's just, you know, expanded horizontally. So what we can do to figure out all the solutions, we can basically just figure out, you know, when n is equal to 0, we need these solutions to stay between 0 and 2 pi. Now, when we're looking around, here's 0. In terms of 8, this would be 8 pi over 8, and then 2 pi would be 16 pi over 8. So what I'm going to do is I'm basically just going to plug in numbers in for n, and I'm going to keep on adding them to my solution set until they're not between 0 and 16 pi over 8. So the easiest number to pick here is when n is equal to 0. So I'm just going to plug n equals 0, and I get 3 pi over 8. That works. So I'll say 3 pi over 8. And 0 here, I get 5 pi over 8. Got it. Okay, what about when n is equal to 1? Now, it might be helpful to remember that pi is equivalent to 8 pi over 8, right? To add fractions, since I don't have room to show my work, I'm going to be doing this in my head. So when n is equal to 1, I get 8 pi over 8 plus 3 pi over 8, which is 11 pi over 8. That works, right? It has to be less than 16. Add over here, this is going to be 8 pi over 8, which would be 13 pi over 8. That one works as well. Okay, and n was equal to 2, that would be 16 pi over 8. That's obviously not going to work for either one of those. And if n is equal to negative 1, that would be 8 pi over 8, but these would both be negative numbers, which does not satisfy my restrictions. So therefore, these are all of the solutions to this equation. Now let's go and work on our last one here, guys, before I go ahead and take a break. And then hopefully I can finish up here rather quickly and get on to some of your guys' questions. So the same thing's happening here. You know, we can just, now in this case, I'm not going to use substitution. I'm just going to rewrite the equation. Tangent of x over 2 equals the square root of 3. Now, if you remember, let's kind of cheat a little bit. It wasn't that long ago that we tried to figure out tangent of alpha square root of 3 over 3. We got pi over 6, right? So the tangent is square root of 3 is just going to be pi over 3. So I can say, using my unit circle here, that's going to be pi over 3 and pi over 3. I should have done a negative 1. I don't know why I didn't do that. So, all right, here we go. So I have So I have x over 2 is equal to, So again, now here, we can actually write a solution between them, right? I can write x over 2 equals pi over 3, and instead of doing also 3 pi over 3, 4 pi over 3, I can just do pi over 3 plus pi n. Okay, so this equation satisfies both of these solutions, right? Both when tangent's positive in the first and the third quadrant. So now, to get rid of my 2 in the denominator, instead of dividing by 2, I need to actually multiply by 2. So I'm going to multiply by 2 on both sides. So in doing that, I get x is equal to, make sure you distribute here, 2 pi over 3 plus 2 pi n. All right, so that's going to be representing all of my solutions. And if I want to find my solutions between 0 and 2 pi, again, I'm just going to pick numbers for n. Well, notice, I mean, if n is 0, that gives me one value, 2 pi over 3. And again, think about what is x divided by 2. That's horizontally stretching the graph. We're going to have less intercepts, right, when you horizontally stretch the graph. And again, you can think about that. Like when you add a period, which is now plus or minus 2 pi, it's not going to fall within the restriction of 0 and 2 pi. So, that was all my free response questions, guys. Here are some multiple choice, which I will knock out rather quickly in just a second. But I wanted to check in on your mom, who just commented, so therefore they get the first shout out of my nice little break. Well, happy my restrictions explanation helped out. You know, obviously I'd like to. It's kind of hard with homework, you know, doing. Trying to getting deep with my explanations. So I'm glad that kind of worked, because it is kind of a tough thing. I want to teach, obviously, but I absolutely don't want these live streams to be like 3 hours long, because my students need the answers, right? And they've already been taught this information, and you guys are coming from all different directions. Some of you taking pre-calculus, some of you already know this, some of you have no idea what's going on. So, I just try to do the best I can. So I'm happy that helped. I need help on quadratic formula and the perfect square trinomial. Distort, if you have a question that you want, like if you actually have like an equation you want me to do, let me know, and I'll be able to work on either one of those. Scintilla said you made math easier. Well, you're very welcome. Happy to help you out, Grace. I'm just happy to do what I can, Grace. I definitely enjoy getting in and doing a live stream, even though I have a lot of work that I need to do for class. But it's enjoyable. I enjoy doing these live streams with you guys. I enjoy you guys coming on and asking questions, checking in, and stuff like that. So, do you know I can send you the steps? But Layla, I'm not sure. I have a sheet that I have all the steps. I'm not sure if I know. Oh, perfect square triangle. Oh, you're trying to help out. Well, that's good. I really appreciate you guys helping each other out. He won't respond. What is that? Okay, help me on. I don't know. Help me on systems of equations. Eli, if you have a systems of equations problem, let me know. The problem is, guys, and I haven't worked this out very well, and I do apologize for that. I know some of you, come in, you want some stuff, or me to help you out. But if I don't have, something to go on, then it's kind of hard for me just to guess what you need help on, because obviously just random problems, could be helpful. More likely than not, they're either going to be too easy or too hard, right? So if you have a specific question, I would love to, be able to help you out after I do these multiple choice questions. So again, if you have something specific, then that'd be great. And again, I know that the, YouTube is not very good at this, because you can't really post a picture of that. So I am still kind of having some issues as far as what I would like to do with that. And obviously I've been trying to do on my memberships, trying to let people know when I'm going live so they can submit questions. So obviously if that's something that you are interested in as well, you can, definitely look into that as far as sending me stuff. So therefore I can help you out, because I'm going to go live at least once or twice a week, and, hopefully some of those things will help you guys out. All right. So, when you're starting optimization or first or second derivative test with your class. So I'm actually not teaching calculus this year. So I do have my older videos from the last 2 years of me teaching calculus, but this year I'm just doing pre-calculus. So we're going to be doing limits at the very, very end of the year. Damrayu, but that's about it. And Rick said, you inspire me. Well, I'm very happy to inspire you, Rick, to be a math teacher. My inspirations were all of my math teachers that I had, and so they were all coaches and all into sports. Even though I'm still into sports, but not as big. But they were kind of the ones that got me to want to be a math teacher. And the only thing I can tell you is you're going to have a lot of ups and downs, but just don't ever forget why you decided to be a math teacher. Or just why to be a teacher in general. And I think when you hold on to the reasoning of why you do what you do, it it makes everything worth it, and it gives you the kind of strength when the times get tough. Because obviously, like any occupation, there's tough times with kids, with administrators, with the culture, and all that kind of stuff. And so it's always the storm you're always weathering, But I think if you hold on to the why you're doing it, why you want to become a teacher, why you want to do it, I think you can have great success. And I really do think that our society is going to depend on the generations that we're bringing up, and teachers I think have a big impact on that. Our teachers do have a big impact on that. Must suck for you guys in Florida. We got no school. Well, that's awesome, man. Toxic. I'm from Michigan, so I remember snow days, and I used to love going home knowing there was a snowstorm coming up and I didn't have school. That's a good feeling. But we do have hurricane days, and we've had plenty of hurricane days the last couple of years. So those are not very good because they usually bring a lot more destruction than snow days. Not always. I know there's some pretty destructive snow days, but yeah, we do have hurricane days, which you guys more likely don't have. All right, so Layla, I will get to your question here in just a second. And then, and Omar, you're just going to have to type it out. That's the best way I know how to do. And sorry about that. If you can type it out somehow on the chat, then I'll be able to address it. But unfortunately, that's the best I got. So, all right, guys, I'm going to knock out these multiple choice, and then I will see what questions you guys have come up, and I'll try to do my best for you. Okay, in this example, I have solved for the cotangent of 1 over 3. So remember, guys, that's the same thing as tangent of alpha or theta is 1 over square root of 3, which is square root of 3 over 3. Notice the restriction now is between 0 and 90 degrees. We figured this out, guys, to be the same. If you guys remember up here, square root of 3 over 3 was pi over 6, right? Well, in between 0 and 2 pi, it was pi over 6 and 7 pi over 6. But the only angle that's between 0 and 90 degrees is pi over 6, which is equivalent to 30 degrees, which is our answer, B. Here looks like we're going to have to factor out. We have two terms, so think of this as like a quadratic, like x squared plus x equals 0, right? So factor out the common term, which is a sine of theta. And you're going to be left with a sine of theta plus 1 equals 0. So we have sine of theta equals 0 and sine of theta plus 1 equals 0. So when does sine of theta equal to 0? Well, on the unit circle, sine, which is the y-coordinate, is equal to 0 at 0 and pi, right? And again, I didn't write in the restrictions, but you can see all these problems are covered there. Okay? So then we have sine of theta equals negative 1. Well, again, sine is equal to a negative 1 on the unit circle. That's down there, which is the angle 3 pi over 2. Not the pi, so that one doesn't work. Not pi. Oh wait, we already had 0 pi. Idiot. That's actually is the answer. So we have 0 and pi, which satisfies this equation. And then 3 pi over 2 is the only angle that satisfies this one. So none of these else have 3 pi over 2, so that's your angle C. All right, question number 3 here. This says secant of x minus 2 equals tangent of x. Now, I like this problem because, what do we do? We can't, factor this whatever else. So what are we going to do here? Well, remember, we can use our Pythagorean identities. If we see trigonometric function squared, why don't we write this in terms of a trigonometric function? So what we can do here is replace secant with tangent squared of x plus 1. So therefore, I can write this as, let's write this over here. So I have tangent squared of x plus 1 minus 2 equals tangent squared of x. All right. And so in this one, if you look at this, now when I try to solve this, minus 1 equals tangent squared of x. When I try to isolate my tangent of x divide up, subtract to 0. So I'm left with negative 1 equals 0, which obviously is not an equation, does not work, so therefore there is no solution. All right, last one. How many distinct solutions does the equation sine of 3x equal 1/2 have on the interval 0 to 2 pi? So Again, we have an inner to find, so I know it's not going to be infinite many. Let's figure out when is sine of theta equal to 1/2 on the unit circle. So that's from here and here, right? 1/2. Sorry, that's not there. That's going to be at pi over 6 and 5 pi over 6. So let's write this out. Even though we don't need to figure out the answers, I'm going to use this as, we don't need to figure out the answer, we just need to figure out how many. So it's 3x is equal to pi over 6 plus 2 pi n, and 3x equals 5 pi over 6 plus 2 pi n. All right, so now I divide by 3 to solve for my x. Divide by 3, divide by 3. And I get x is equal to pi over 18 plus 2 pi over 3n. Here I get x equals 5 pi over 18 plus 2 pi over 3n. So again, remember, we're just going to look into adding our values here, adding values for n. Now, it'd probably be better to write 2 pi over 3 in terms of denominator 18. So let's write this as x equals pi over 18. And to get this as a denominator of 18, I'm going to multiply by 6 over 6. So this would be 12 pi over 18n. And this would be x equals 5 pi over 18 plus 12 pi over 18n. Okay, so between 0 and 2 pi. So when n is 0, I get pi over 18 and plus 5 pi over 18. And then when n is equal to 1 here, you can see that's going to be 13 pi over 18. Why am I doing adding? That's not adding. So I'd have 13 pi over 18. And there probably is a quicker answer, but I'm kind of feeling a little bit, or the quicker way to do this, but my eyes are kind of feeling a little tired, so I'm just going to work through this the long way of actually just finding all the solutions and then counting them. This would be 5 pi plus n equals 1 would be 17 pi or 18. When n is equal to 2, that's going to be 24. Now again, remember 2 pi would be 36 pi over 18, right? So we're kind of running out of space, so I'm going to continue this down. So we have 17. So if this is 2 pi, that'd be 24 plus pi, which would be 25 pi over 18. This would be 24 plus 5, which would be 29 pi over 18. And then let's multiply where n is equal to 3. So that's going to be 36. Nope, that's not going to work. So therefore, 1, 2, 3, 4, 5, 6. 6, my answer is C. Boom! There you go, ladies and gentlemen. That is it. Hopefully that homework has helped you guys out. Zoom that in. So now, guys, I'm just going to go ahead and play around and see if there's any questions I can help people out. So, oh, Layla, you got too many questions. 3 questions? Come on. All right, I'll see if I can do one and then see what I can do. The question is, 2 numbers have a difference of 24 and a product of negative 135. Find the numbers. These are always like tricky ones that like I always get wrong. So, all right, I'll go ahead and on the spot I'll try to see what I can do. So we have 2 numbers. 2 numbers have a difference of 24, and their product is negative 135. So 2 numbers. We don't know what these numbers are. So let's just do x, minus y is equal to 24. And then we have x times y is equal to negative 135. Okay, so I don't have a calculator with me, but all right. So what I would recommend doing in this case is, so we have a system of equations here, right? We have 2 variables and we have 2 equations. And whenever we have 2 variables and 2 equations, that's what we want to go ahead and solve with here. So we have the difference of 2 variables, 2 equations is 24, and then the product is negative 135. Now, what we want to do is basically solve for one of these equations and for the other variable. Now, in this case, let's go ahead and take the top equation. It looks like the easiest variable to solve for would be x. Because to solve for x, all I need to do is just add y to both sides. So I have 24 plus y, right? And now, since x is now equal to this quantity, 24 plus y. So now wherever I see an x, I can just replace this with 24 plus y. So I'll write 24 plus y times y equals negative 135. Now, to go ahead and solve this, I'm going to actually have to distribute this, and I'd have 24y plus y squared and equals negative 135. Now set this, you see this is a quadratic with two variables, so therefore I have y squared plus 24y, and then add 135 to the other side. And now we need to solve something that multiplies to give you 135 and then adds to 24, which is very big numbers to go ahead and do. And let's see, 5, that's 27, no, that's not working out. I'm not sure, but hopefully that at least gives you a start off. And obviously I'm not with my calculator, but I also don't want to take too much time. So hopefully that at least gets you started with there. How do you know it? Okay, hold on. There was another question Omar had. All right, Omar wrote out his question, which was dedication. So I got to answer that one. Distort, I'll get to that. Teach. All right, so we have a verifying identities by Omar. So that's cosecant squared of beta minus sine squared of beta equals 1 minus 2 sine squared of beta. Okay. So the only thing I can think of right now is to combine these. So let's work on the left side. Let's rewrite this as in the same denominator, sine squared of beta minus sine squared. Actually, you know what? Stop that. No, yeah, that wouldn't work. Okay, let's try adding them, see what happens. So I'd multiply by sine squared of beta on the top and the bottom. That's going to give me 1 minus sine to the 4th beta over a sine squared of beta. And that's supposed to give me my 1. Now, no, that's not going to help me out any either. Well, let's see here. I could, that'd be 1 sine squared of beta times 1 plus sine squared of beta. But I'm not really getting myself anywhere here. Because then that would just take me to sine. So Omar, I'm trying to think what I could do. And I don't know, you think you might got me on a tough spot? I might have to come back to that one. Because I'm not thinking of anything. Adding them's not going to help out. Just multiplying by the sine, which would have been the same thing, doesn't really help. Like, that takes you to 1. But then that gives you sine to the 4th, so that doesn't really help you out. And again, it's also something I'm not sure if using, I'm thinking other identities, which we don't cover, so I'm not as familiar with, which actually I erased. I'm thinking, hold on 1 second. trying to think if there's any other identities. I'm not going to spend too much time on this if I don't know the answer, because you can definitely go onto other websites and check it out. But it doesn't seem, I'm trying to think, I'm thinking this would be, yeah, that's going to be, I bet that's probably going to be a power reducing formula. It'd probably be the easiest thing with, if you did the sine squared, that'd be 1 minus cosine, maybe times u. Maybe that would work out. I'm not sure. But we don't cover the power reducing formulas. So, I mean, that's the only thing I'm thinking, because I'm not seeing anything else with here. So, I'm sorry, Omar, you got me. Well, you didn't really get me. I didn't really spend too much time on it. But as far as the end of the live stream, I don't want to spend the next 30 minutes figuring out, because that's sometimes some of these problems will do it. But I'm not coming up. I don't have a quick, easy answer for you. So unfortunately, I'm just going to have to pass along. But my inclination, what I would do next would look into my power reducing formulas and do that for sine and see if that helps out either on the left side or the right side. See if that gives me my answer. Because initially what we work on, what I've seen as far as doing this, I'm not getting anything that for a quick step. So sorry, I don't have a quick answer for you, but there it is. And there you go. We have a nice little, Agwal is providing some solution, maybe. Solve, oh no, he's giving me another answer. Dang it. Which I'm having a trouble understanding what I need to solve for. So maybe if you let me know what I need to solve for. And again, guys, if you're, so I'm not sure what I need to solve for. But let me kind of come back here just real quick. See if there's any other answers of people that provided. Distort, how do you know the following is a perfect square? Okay, so let's cover this, Distort, because you did ask that question, and then I'll work my way down. And just so you know, guys, I'll probably work on here for like another 5 more minutes. I'll cover a couple of you guys' questions here. So we have m squared minus 18m plus 9. So the basic, like, we could talk about this as far as the perfect square, like the visual representation. But the basic idea here is the first term and the last term need to be square numbers, right? Now, obviously, for a variable to be squared, it's just, it's the variable squared. As far as our numbers, our squared numbers are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, is it 180? Dang it, I lost it. I think is it 189? Dang it. No, 196. I think. Now I'm like losing my mind. Yes, it's 196. And then 4. No, so that'd be, I can't remember. I think that's how far I have memorized. But either way, most of these numbers are going to stay under 100. So here are your square numbers, right? So let's call these a squared. Now, a then is the square root of those square numbers, which would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, 15. I have that, 225. But that's how far I memorized. Okay. So if you're looking into, like, how do you know if something's a perfect square trinomial, it's going to follow, like, these rules. So remember, a and ab, these are real numbers. So these are not variables. Okay? So let's just do it m. It's going to be m squared. So m represents your variable. So it's going to be plus, so minus, it's either going to be minus 2a plus a squared, or actually, let's just do this. It could be plus or minus a squared. Oh, shoot. So if it shows up into the form of m squared, where m represents your variable, it could be x too, right? In this case, you have m. Plus or minus, your middle term is 2a, and that's an x, by the way, which I forgot to write into there, 2ax. 2ax. Oops, not x. We're not using x's. We're using m's. 2am plus a squared. So if you look at this one, we say, all right, if this is a squared, then that has to be 3 squared, right? And if this is a perfect square trinomial, which I believe your question is, how do I know if the following, okay, so And then you can see this is not a perfect square trinomial because a perfect square trinomial would be m squared minus 2 times 3m plus 9, or plus 3 squared, right? And so therefore it would be m squared minus 6m plus 9. And the reason why is because that can be factored into m minus 3 times m minus 3, which is a perfect square trinomial. Whereas this one can't be factored down. Like there's not two numbers that multiply to give you 9 that add to give you negative 18. That's why that's not a different perfect square. So using the variables, I don't like m, but you can see that is your general definition of a perfect square trinomial. You are very welcome, Grace, if you're still there. So happy to help you out. Kennedy, happy help. This is such a simple, it's an 8th grade question in India. I'm not sure what you're referring to. Rose, taught me more. Happy to help you out, Raw Girl, on your grassing. Awesome to hear, Louiso, you passing. Good for you. Let's see here. Why does 5x minus 7 plus 5x while solving equations by graphing? So it looks like that's a systems of equations. All right, so I'm going to do is I'm going to write down some problems that I'll cover, and then that's what I'm just going to shut off at. So y equals 2x plus 2. All right, and Carrie, Parker, math. Best of luck on your midterm, Tom. Could you tell me how to insert 4 sine of pi over 2 in a scientific calculator? Typically, you'd probably need to type in, Rago, you'd probably need to do pi over 2 first, then type sine, and then type multiply by 4. I don't really use a scientific calculator, and all scientific calculators are different. So yeah, but I'd give that a shot. Carry objective function. Sorry, that's going to be too much of a problem for your perimeter function. It's going to take me a little bit too longer to kind of cover that at the end. Awesome. So sweet. So let me see. Cosine squared minus sine squared. So what'd you do? Then left 1, 2. Yeah, but then you're switching from one side to the other side. I get that, and I see your solution. That will help. A lot of times when I'm doing my verifying identities, you can, like I'm not using switching one side to the other. So we're just looking at algebraic operations that are remaining on one side. So what can you do on one side that is going to make it look like the other side rather than doing operations on both sides? But yeah, that looks good as far as using your, although I'm not seeing cosine. Where'd you get in cosine minus sine squared? Equals 1 minus 2 sine squared. Oh, but either way, thank you. I appreciate that. Actually, I'll have to look more into it. No. Actually, I'll go on. I read that. It looks good. Please, I read your solution. Please read your solution. I see your solution. Stop asking. You read it already. Jeez. Yes, thank you. All right, so let's go and look at an example here. And thank you very much, Asha Agwal. I do appreciate you providing that solution. I'm not still sure where the cosine squared minus sine squared equals 1 minus sine squared. I guess if you just simplify those two, then that would make sense if you rewrite that cosine. So I do appreciate that. Okay. Well, either way, my brain's kind of all over the place, so I'd like to work it out and show it. But either way, that's either way, I think your solution should suffice for anybody that's going back through the stream, so I appreciate it. All right, so the system of equations, we have 2 equations. Now, if we want to solve this, at least the problem was posed to me was having them set equal to each other. Now, I'm not sure, where it looks at. So basically what we're doing is we're trying to see, well, what are the values, when is the x values going to be equal to one another? And if we just go ahead and solve for x, it doesn't matter which x variable on which side you want to solve for. So 3x minus 7 equals 2. You add 7 to both sides, and I get 3x is equal to 9. Divide by 3, x is equal to 3. So that means the variable 3, when x is equal to 3, both equations have the same output value. What is that output value they have? Well, let's plug 3 into both these equations. Y equals, now, does it matter which equation you plug it into? No, it doesn't. So to show that, I'm going to plug it into both. So we have 15 minus 7, which is 8. And here I have 6 plus 2, which is 8. So if I was just going to plot this on a system of equation, I would have 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7, 8. Now that's how the question was posed to me by the student. So I believe that's what they wanted me to show, not so much as far as how to graph these two equations and find their intersection point. But if you were to graph them, 1, 2, 3, 4, 5, 6, 7, and then 1, 2, you would see that they would intersect at this point. And I hate drawing lines in this, but when I do that. All right, guys, it's getting late. I got to end off the stream. But let's see. Parker says, Brian, this is all easy to me, but I have used U in the past to solve for U. Yes, U is definitely works. U for U substitution, or U for substitution works as well. So that's a great way to do it. Yeah, cosecant is my cos. Oh, okay. Interesting. Anyways, I appreciate it, guys. Thank you again, Asha Agua, for adding in that commentary. Thank you guys for joining in my chat. I wish you guys a great week. And then I'll let you know how the quizzes go. And I will go over those solutions on my quiz maybe later this week for another live stream. So until then, though, guys, I am signing off. Hope you guys, again, have a great one. And I'll talk to you next time.